Hello and welcome back. In section 2.3, we continue our 2.2 work, but we cover some special cases. We looked at some of these in 2.1. Now we'll be actually going through the work of solving them using the 2.2 process of statements and reasons. So for our first one, our domain is going to be I, the set of integers. So our equation, and I'll just put it in the statement column, will be 11x minus 3 is worth 11 times the quantity x plus 1, close it up, minus 14 outside, and that will be our given. So this one, as you can see, the left-hand side, we don't have any like terms, no grouping symbols to worry about, anything like that. The right side, we do have some grouping symbols. So we'll start with taking care of that, removing the parentheses, and that is using the distributive property. If you want the full name, distributive property of multiplication over addition. Distributive property is fine to write as well, though. Then we'll take care of our arithmetic. So 11 by 1 is 11. 11 minus 14 is negative 3. So next, if you have x's on both sides, use the addition property of equality to fix that. So even though we're writing a minus 11x on both sides, that is still under the property name of addition property of equality. Subtracting 11x and adding negative 11x is the same thing. So there is no name for subtraction property of equality. That's not a thing. Addition property of equality is our property. Adding a number and its opposite, we always get 0. That is the additive inverse property. Zero minus 3 is negative 3. Additive identity property. Your author takes one more step and sets the left-hand side to 0. Really, once we have just a constant on each side, you can still make your decision off of that. Now, since this one is always going to be true, negative 3 is always going to be worth negative 3, this was an identity equation. So then our solution set would be the set of all x such that x is in our given domain. In this case, our domain is the set of integers. So any integer you want, since that's our domain, plug it into the original, you get a true statement. Plug in 0, you get a true statement. Plug in another integer, negative 1200, you'll get a true statement. Plug in 5280, you'll get a true statement. This works for any integer. The reason being that this was an identity equation. If we get this variable dropping out and the same constant on both sides, this was an identity equation. Okay, so similar to the 2.2, we're using the same processes. We just have some outcomes that we didn't explore in section 2.2. So next one, our domain is N. So we'll start with a 6x minus 1 is worth 2x minus 9 as our given. This time, no distributive property to worry about as far as knocking down parentheses, but I do have variables on both sides. We'll fix that using the addition property of equality. So I'll subtract 2x on both sides of the equation. And remember that hint, if it's happening to both sides, it's one of the two properties of equality, and you just have to pick, is it addition or multiplication? So then we simplify either the right or left side. Next, I'll just work left to right. So we have 6 minus 2 of the x's minus 1 by the distributive property. So left side by arithmetic is now 4x minus 1. Right side, we'll bring it down, 2x minus 2x minus 9. So even though we don't know what 2x is worth, we do know 2x and negative 2x are additive inverses, so they will add to 0. And usually after you see the inverse, you'll see the identity. That's not a hard and fast rule. It's just something that often happens. Okay, so now we have all the variables to one side. We'll move all the constants to the other. So addition property of equality coming up again. So negative 1 plus 1 will add to 0 because they are additive inverses. And even though I don't know what 4x is, 4x plus 0 will always spit out a 4x. Hopefully you remember why that is. The additive identity property. Next, we'll take care of a little bit of arithmetic on the right-hand side. All right, so I'm going to pick this up on the next page. So we left off with 4x is negative 8 by arithmetic. All right, so that's what we had at the bottom of the other page. So now we're doing something to both sides again, so it's going to be another property of equality. This time, multiplication property of equality. And we'll regroup the left-hand side. So that is the associative property of multiplication. One-fourth and 4 are multiplicative inverses, so that is the multiplicative inverse property that will get us to the 1. And even though we don't yet know what x is, 1 times x will always spit out x because that is the multiplicative identity property. And we finish it off with arithmetic. Now recall for this one, our domain. Our domain was n, the set of natural numbers. -2 is not in the set of natural numbers. So our solution set is empty, and we show the reader why by doing an Euler diagram. So here's our Euler diagram of the real numbers. I think most of you have gotten the Euler diagram of the real numbers down by now. So our domain was n, the set of natural numbers, so we lightly shade the domain, and then we place the value we got into the drawing. In that case, the -2 is real, rational, and an integer, but not a whole, not a natural. So there's our domain, and there's our potential solution. That's why we ended up with the empty set. If our domain was just the regular integers, we would have been perfectly happy to drop the -2 into our solution set. So it just depends on what domain we're working with. What is the universal set we want? Okay, next up, another special case one. 7x plus 2x minus 3 is worth 9 by the quantity x plus 2. That's our given. And we'll start with simplifying the left-hand side. So I have 7 plus 2 of the x's minus 3. And I'll just hang on to that right side for now. So that is the distributive property. Arithmetic gets us to 9x minus 3. So I just took care of what was in the grouping symbols there. That's all the simplifying I can do on the left-hand side. So now I'll work on the right-hand side. We'll bring this left side along. 9 times x plus 9 times 2. So that was the distributive property used a different way. So before we used it to create parentheses, now we used it to remove them. We'll do the arithmetic on the right-hand side next. Variables on both sides, so addition property of equality to fix that. So subtract 9x on both sides. That's by the addition property of equality. (9x) and -9x are additive inverses, so we get to 0 minus 3 on the left, 0 plus 18 on the right. And 0 minus 3 is -3, 0 plus 18 is 18. Those are both the additive identity property. So I did the same work as before. I got down to a place where I have no more variables, just one constant equal to one constant. What's different about this one than the first example today is that now I have a statement that doesn't make any sense. -3 and 18, definitely different numbers. When that's the case, our solution set is empty instead of being everything in the domain. The reason why this was a contradiction. So it's not one of those where if I expanded the domain into a different set, I would be able to keep some solution. No matter how large a number set I worked with, I can expand all the way beyond the reals and into the complex numbers as well. We'll talk very little about those in a while, but even beyond the set of real numbers, nothing was going to work for this. Nothing would ever help. So any number you want, any real number, so pi, e, -1, +6, 0, 9/16, anything at all you try, it's guaranteed to give you a false statement in the original. We'll never be able to solve that equation since it's a contradiction. Okay, maybe I'll try one out. Starting with the given as usual. So let's see, so we'll do 7 by x minus 1 is worth 4x minus 1. So for this one, if they don't state the domain, recall unstated domain in chapter 2 and 3 means the domain is I, the set of integers. So go ahead and pause the video and see what you can do with that. Okay, welcome back. So hopefully you started with the distributive property on the left-hand side. And then follow that up with arithmetic. Then you notice you have variables on both sides. Fix that. So we'll subtract 4x on both sides. If it's happening to both sides, it's one of the properties of equality. In this case, the addition property of equality. So then you might have done the steps in a different order than I did, but you do have to have all the steps that I have. It just depends on if you did the left side first or the right side first. I'll just do the left side first. So to do that, we would use the distributive property. Then take care of the arithmetic. So inside of the parentheses there, the arithmetic. So again, if you took care of the right side first, after your right side, these would be the 3 steps you'd see. Those of you that, like me, did the left side first, just keep following along. So 0 minus 1, that is the additive inverse. So 3x minus 7 is -1 by the additive identity. So next we move the constant. So I add 7 to both sides. That's another addition property of equality. If you took care of the left side next, you had the additive inverse. Followed by additive identity. Followed by arithmetic. All right, so then we get to 3x is 6, so I'll multiply both sides by 1/3. Anytime you're seeing something happening to both sides, it's going to be one of those properties of equality. This time multiplication, property of equality. Then we regroup. So 1/3 by 3 get grouped together instead of 3 and the x grouped together. It's worth 1/3 of 6. So that's the associative property of multiplication. Multiplicative inverse gets us to the 1. Multiplicative identity gets us to the x by itself. And we close it out with arithmetic. Our domain was given as I. 2 is in the set of integers, so we get to keep it. And so no special work to be done with this one. So the next problem that I'd like you to try, let's start a fresh page here. So do 2 by the quantity x plus 5 is worth 7x minus 5x. So go ahead and pause that, see if you can run through it, come up with a solution, and the domain, since we haven't stated it, assume it is I, the set of integers. Okay, welcome back. So we'll start, those of you that started on the left-hand side, we'll start with the distributive property. Followed by arithmetic. Then we have a little bit of distributive property to do on the right-hand side of the equation. Followed again by arithmetic. Variables on both sides, we fix that next. If it's happening to both sides, it's one of our properties of equality. So this is addition property of equality. So additive inverse gets us to 0 plus 10 equals 0. Additive identity gets us to 10 equals 0. So once we hit constant equals constant, no variable left, we're left to decide, is this true or is this false? This one clearly is false, so we would have the empty set. This one was a contradiction. All right, so next up, I'll have you all try out. Here's another statement and reason. So let's see, so we'll do -2x is worth -2 by x plus 1. Close it up, plus 2 as our given. Our domain is going to continue to be I. So go ahead and pause it, give that one a spin, unpause it when you're done. Okay, welcome back. So we'll bring that left-hand side along. Right side, we have the distributive property. So you might have noticed that the distributive property and arithmetic are sort of acting as teammates here as well. Again, it is possible to do other things in between them. It doesn't have to always be done in that order, but it does seem to help students if they do it in the same order each time. All right, -2 plus 2 is 0. That is the additive inverse property. Additive inverse, I don't know where that I came from. And then the additive identity. So then we'll finish it off. Another property of equality. I'll try to get my variables onto one side. So I'll add 2x to both sides. Addition property of equality. And we have the additive inverse again. This time, no other work to do. And we're left with a true statement. So then our solution, set of all x such that x is in, and then whatever the domain is for the problem. For this problem, it was I. If the domain had been n, set of all x such that x is in n. So this one is always going to be true. And have you all try one more out. I'll make this one a little bit shorter. Okay, so that will be our given. Domain, this one, we'll make it I. So go ahead and pause it, give the problem a try, unpause it when you're finished. And welcome back. So no simplifying to do on either side, so we'll jump right in with the addition property of equality. We'll subtract 2x on both sides. So 6 minus 2 of the x plus 24 is worth 2x minus 2x plus 5. That was the distributive property. Again, if you simplify the right-hand side first, just you'll see all the same steps, just in a different order than I'm writing them. So arithmetic next, so 4x plus 24 is worth 2x minus 2x plus 5. That was by arithmetic. So 4x plus 24 is worth 0 plus 5. That is additive inverse. So 4x plus 24 is worth 5 by the additive identity. So again, you see these two working together. They don't always have to be in that order, but they tend to happen together. So then we move our constant, so addition property of equality again. So 4x plus 0 is 5 minus 24 by the additive inverse. Additive identity gets us to the 4x. Then we take care of the arithmetic on the right-hand side. So we have 4x is worth -19. We'll multiply both sides by 1/4. So 1/4 of 4x is worth 1/4 of -19. Happen to both sides, so it's one of our two properties of equality, in this case multiplication. We regroup the left-hand side. That's the associative property of multiplication. Any number times its reciprocal is 1. That's the multiplicative inverse property. And 1 times x is x, no matter what number x happens to be worth. That's the multiplicative identity. And we'll finish it off by arithmetic. So positive by a negative is a negative. And let's see, so 4 will go into 19 4 times with 3 left over. So -4 3/4. Okay, that is definitely not in the set of integers. So that was arithmetic. So this was one from section 2.1, the no solution in the stated domain. So our solution set is empty, and since it is possible that we could have kept it had we just had a different domain, that's the case where we then make our little sketch here of the Euler diagram of the real number system. So we'll lightly shade in the integers, which remember do include the wholes and naturals. So you're shading the whole thing, not just the outer layer, the outer sort of donut shape. It's the whole thing. Everything within that is within the integers. But our solution was -4 3/4, which is a rational number and a real number, but not an integer. Okay, so that should be enough for you to try out the 2-3 exercises. So keep practicing on those statements and reasons. You should see a lot of familiar patterns emerging, though, in the order that you do those. You'll see that really they're not as tough as they look. It's sort of the same couple steps broken down, and you see them over and over. If you have any questions, please get in touch. Otherwise, I'll see you next time. Stay safe out there.